Okay, so here it says the graph of this linear function is shown for y equals f of x. What is the y-intercept? So the definition of y-intercept, that is where it crosses the y-axis. That's what we're asking you. So in this graph, where does this graph cross the y-axis? So this is our graph. This is the y-axis. So this would be my y-intercept where you see that red dot. So go ahead and look at that and select A, B, C, or D. So which one would you choose if this was on your SAT? Isaiah. D. Anybody else agree with Isaiah? That is correct. Good. All right, now let's get to our blue notes. In the front of your blue notes, so every single day for my new people, you're going to take out your bell work and your notes. We should all have a binder that you're putting this in. If you have your binder from last semester, you can empty it out and start fresh. Okay, so you don't need that material from last semester moving into this semester. Or you can buy another binder if you really don't want to get rid of it. Okay. All right, so now let's go to our note packet. On the cover, can you write your name, the class period, the test date? I'm going to have you fill that in tomorrow because that might change since we had a snow day and a delay. So we'll leave that blank for now. Okay, so what we're talking about today is the inverse of a quadratic. So what I want you to do, off to the side, I want you to graph this table. Go ahead and graph this table on the coordinate plane. So this is y equals x squared. So we're going to go ahead and graph it. So we're going to put a point at -2, 4. Put a point at -1, 1. Put a point at 0, 0. 1, 1, and 2, 4. And then connect it. And this is called a parabola. It looks like the letter U. Sean, can you take your headset off for me? Thank you. Okay, so now we're going to talk about the inverse, and that's what this whole unit is about. It's about the inverse. And the inverse is what you get when you switch it. So what I mean by that is all of the numbers in your X column, you're going to write here in the Y column. And all of the numbers in your Y column, you're going to write in the X column. So that's what inverse means. Inverse means you switch your X and Y. Don't graph it yet. Let's just fill in our table. We're going to flip it. So I'm writing all of these numbers here and all of these numbers here. Okay, so that would give us 4, 1, 0, 1, 4. -2, -1, 0, 1, 2. Now remember, everything in this column, all of your X values, we're really taking the square root of. That's the operation we're doing here. In this one, we were squaring them. That's y squared. But now in the second one, we're taking the square root. Now, if you remember from last semester, I'm going to remind you just in case you don't. If you take the square root of a number, it has to be positive. So I'm going to write that. The square root is always positive. And because of that, we lose some points in our inverse table. Because when we take the square root of 4, we're not going to get -2. And the square root of 1 is not going to give us -1. So we can actually cross those two off our table. So our inverse only has 3 points that we're going to graph. So I want you to graph these 3 points off to the right. So I'm going to put a point at 0, 0, 1, 1, and then 4, 2. And that's what that's going to look like. So I like to say that a square root looks like an eyebrow. I don't know. It only goes one direction. So this is my square root graph. It doesn't look like a U. It's half of a U. Flip down. So for the red graph, if we look at our table, notice that I have positive and negative numbers. That means that my domain is all real numbers. And when I squared it, all of my y values were positive, so that would be y is greater than or equal to 0. But for the eyebrow, which is my square root, all of my numbers, all of my x values are greater than 0, so that would be x is greater than or equal to 0, and my range would be the same. So we're going to start off identifying transformations, and then we'll start graphing it. So it's really important that you understand what the 3 transformations, what they do to your graph. So that's what we're going to spend our time on now. Okay. So let's start off with the first number. So this is my square root function. This is the number in front of the square root. That number, A, has 3 superpowers right here. If it's negative, the graph is going to reflect down. If it is bigger than 1, I'm going to write. So this is what this means. If it's bigger than 1. So if that A value is bigger, and I'm sorry, my little stylus is really having a hard time writing. If that number is bigger than 1, it's going to make our graph stretch. And if it's between 0 and 1, that's what this means. It's going to make it compress. That's what your A value will do. That's the number in front of the square root. If it's a negative number, it's going to make it flip down. If it's a number bigger than 1, that says stretch. That H looks kind of weird. There we go. If it's a number bigger than 1, it's going to make it stretch. If it's a number between 0 and 1, it's going to compress it. That's in front of the square root. That's the A value. The next number we're going to talk about is the number under the square root. So the number under the square root is here. And that's this box. And it's always opposite of what you see. That's why it says opposite. Because whatever you see, the actual H value is opposite. If it's a positive number, it's going to make the graph move right. And if it's a negative number, it moves the graph to the left. And then lastly, we have K. K is the number outside of the box or outside of the root. If it's positive, it's going to move the graph up, and if it's negative, it moves the graph down. So those are your transformations. So before we start graphing, let's practice identifying the transformation and then explaining what that transformation is going to do. So we're going to look at this example together, and then we'll actually start working on them. Let's look at these. These have already been filled out for us. The A value is right here. Because that number is bigger than 1, that's why we said it's stretched. The H value is always under the hood, but it's the opposite. So do you see how it says +1 under the hood? The H value is the opposite, it's a -1. And that moves the graph to the left. The number in the back is a -4, and that moves it down 4. For this next example, we can see that A is a -2. So because it's negative, it reflected down. And because 2 is bigger than 1, it also stretched. The H value is not -5, it's +5, and that's why it said it moved to the right. And the H value is +1, which is going to move it up. All right. For this last one, A is 1/3. 1/3 is a fraction between 0 and 1. That's why it compressed. The H value, instead of saying that it's a +2, is actually the opposite. It's -2, which is why it moved to the left. And the K value is +7, which is why it moved up. So now let's go ahead and do it together. So let's go ahead, looking at these equations, we're going to identify A, H, and K, and then write the transformation. So for this first one, the A value is right here. So that means that A is -1. There is an invisible 1 there. H is under the hood, but you flip the sign. So do you see how there is a +3 under the hood? That means H is going to be what? -3 or -3. Thank you. There isn't a number back here, so our K value is 0. So let's go ahead and write what's going to happen. Because A is negative, this graph is going to reflect down, because that's what we said is going to do. If you go back to the last page, if A is negative, it makes the graph reflect. H is also negative. So is that going to move the graph left or right 3? Left. So let me go back here. Remember, we said if H is negative, it moves it left. If H is positive, it'll move it right. So H is negative, so it's going to go left 3. Ooh, this little stylus is raggedy. All right, next. A is 1/2. H is under the hood. Let me zoom in. Do you see that there is nothing under the hood except for X? Does everybody see that? There's nothing under there. So that means that H is 0. The number in the back is a -2. So that -2 is K, not H. So because that's 1/2 is between 1 and 0, it's going to compress. This one does not move left or right, but it does move down 2 because that K value. All right, let's look at question C. When you don't see a number for A, that means that A is 1. Your H value is what's under the hood, but you flip the sign. So instead of a +4, I'm going to put a -4. And then there's no number in the back, so that means it's 0. So the only change that's going to happen, because A is 1, So that doesn't change anything. But the H value is -4, so it does move the graph left 4. That one only has one transformation. For question D, your A value is 1/3. H is under the hood and you flip the sign, so that would be -1. And there is no number in the back, so that would be 0. So because A is 1/3, is that going to make it stretch or compress? Compress. And is it going to move left or right? Left. And it does not move up or down. All right, I want you all to do this last one on your own. I'm going to come around and check what you write. Try to do that last one on your own. So because A is negative, I'm sorry, A is 2. Sorry, never mind. I take it back. A is not. So this is going to be the opposite. So instead of +2, so -2. Not bad. We at least got our A, H, and K right, so I appreciate that. So we can talk about the transformations together. So A is what? What did you say for A? A is 2. So I'm going to go back 2 slides. We said for A, if it's bigger than 1, it's going to make it stretch. But if it's between 0 and 1, it compresses. So is 2 bigger than 1 or less than 1? Bigger. So you should have wrote that it's going to stretch. I think that's the only one that's kind of tricky. The H value, I guess the H value is tricky too, because you have to remember to flip the sign. So H is -2, which is going to move it to the left. Let me go back. When H is negative, we said the graph moves left. And then lastly, your K value is the number in the back, which is 6. 6 is positive, so is that going to move the graph up or down? Up. All right, so we're going to do one graph together, and then I'll pass out your homework, and you can start working on that. So I'm skipping over example 2. Let's just go straight to example 3. You can cross out example 2 because we already did that at the beginning, so we don't need to do it twice. So the first thing we're going to do is graph this table right here. So I'm going to write, this is the parent table for a square root. 0, 1, 4, 9, 0, 1, 2, 3. That's your parent table. So in other words, if I take the square root of 0, I get 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. I want you to graph these 4 points. It should look like an eyebrow. Go ahead and graph these 4 points over here. It's going to start at 0, 0, and it's going to continue going to the right. So we got a point at 0, 0. We have a point at 1, 1. We have a point at 4, 2. And we have a point at 9, 3. And this graph only has one arrow. So it has a point and an arrow. That is your parent function. So whenever we talk about it stretching, compressing, moving left, moving right, we're always comparing it to this. This is what we call the mama graph. This is the mama. Everything is compared to this. All right, so now let's go ahead and graph this. Let's go ahead and put it into play. Looking at this equation right here that I have highlighted in blue, go ahead and list A, H, and K. Take a minute for that blue graph, the blue equation. Tell me A, H, and K. So A is the number in front. If you don't see a number, that means that A is what? 1. H is under the hood, but you flip the sign. So it's not a -2, it is a +2. And K is the number in the back, so that would be 3. This is not going to change our graph, but these two will. So when I compare it, my second graph, when I compare it to the mama, these two are going to change it. Because H is +2, is that going to make the new graph move left 2, right 2, up 2, or down 2? Right 2. So let's write that down. That's our first change. When we talk about a transformation, we're saying, how does it change from the mama? And the 3, is that going to make it move left 3, right 3, up 3, or down 3? If K equals 3, what is that going to make the graph do? Up 3. All right, so this is how we make our new table. Remember, this is our original table that we always start with. All right, so whenever you're doing your table, though, you always add H to the X. So let's start off with that. So we said H is 2. So what I want you to do going down the side is I want you to put a 2. Go ahead and add 2 to these 4 numbers. These are the same numbers that we have up here in red. These are the same numbers that's already here. So you're going to add H to 2. So you got 2 plus 0, 2 plus 1, 2 plus 4, and 2 plus 9. Go ahead and get your new 4 numbers. So 2 plus 0 is 2. 2 plus 1 is 3. 2 plus 4 is 6. 2 plus 9 is 11. For your Y values, we do 2 things. The first thing we do with Y is multiply it by A. The second thing we do is add K. So A is 1 and K is 3. So I'm multiplying these numbers by 1 and adding 3. Now, when you multiply a number by 1, it doesn't have an effect. So we really don't have to write it, but I don't want you to forget that we multiply Y by A, so I'm going to write it anyway. So you're taking 0 times 1 plus 3, 1 times 1 plus 3, 2 times 1 plus 3, and 3 times 1 plus 3. I'll give you a minute to get those 4 numbers. All right, so what did you get for your 4 numbers? So what's our first number? 3. Our second number would be 4. Next number would be, and last number would be. All right, so these are ordered pairs. Go ahead and graph these 4 points. Put a point at 2, 3. Put a point at 3, 4. Put a point at 6, 5. Put a point at 11, 6. 11 doesn't fit, so don't worry about that last one. And you should have a second graph. And if you compare the red graph to the blue graph, we can see that it moved, the red graph moved right 2, and it moved up 3. just like we said it would do. So the last thing we need to do is write our domain. Did I miss anybody passing out the homework? All right, so the last thing we need to do is write our domain and our range. So for our domain, the domain is always going to start with x is greater than or equal to. And for our range is y, that's going to start with y is greater than or equal to. So if we look at our table for our x values, when you compare the two moving down, are these numbers getting bigger? So we started 2. Are these numbers getting bigger or smaller? Bigger. So that's why it's greater than. So while x is greater than or equal to 2. And then what's our first y value in our table? 3. Our y values are greater than and equal to 3. All right, so for the rest of the class, you have a couple of things. If you were absent yesterday, you have the assignment you missed yesterday, which for my new people, everything is turned into the blue tray in the front. Don't hand me anything. So as soon as you get that done, remember the coloring is extra credit. I do have crayons in the back if you want to finish that out today. Get that turned in. This assignment that I just passed out, because of the snow day, can you write that the new due date is Friday? Not Friday, sorry. Tuesday, January 14th. So can you write that on the homework that I just passed out? It is due Tuesday, January 14th. So use this time. You can do the whole front side of that homework. You can at least do AH and K for number 1 and start writing the transformations before you leave. If you have any questions, raise your hand and I will help you.